Oh, sorry, didn't see you there. Today, we will be talking about epinephrine and stuff. Specifically, we'll focus in on epinephrine, norepinephrine, and isoproterenol. These are all direct sympathomimetics. But before that, let's do a very quick and unnuanced review of sympathetic receptors. Alpha 1 tends to constrict vessels, alpha 2 keeps it in check, beta 1 makes the heart go into power mode, and beta 2 dilates peripheral vessels. Epinephrine stimulates beta receptors more than alpha, and especially is stimulating to beta 2 receptors. Norepinephrine stimulates alpha 1, then alpha 2, then beta 1, in that order. Isoproterenol stimulates beta 1 and beta 2 receptors equally, but not alpha receptors. So remember that to say epi, you start with your mouth open, kinda like what beta 2 does to blood vessels, it opens them. Epi. Norepinephrine does the opposite. It's no epinephrine. Yeah? And isoproterenol sounds like a beta blocker, but it's not. But the iso should at least help you remember that it affects beta 1 and beta 2 equally. Now, normally I would have drawn out some pictures and diagrams myself, but First Aid does a much better job. If you have the 2016 version like I do, go to page 247 and just take a look at that. It's a very great diagram. So flip to that page and follow along with the rest of the video. This will help. Since norepinephrine and isoproterenol are the most different from each other, let's compare those first. Norepinephrine causes a rise in diastolic blood pressure because of the alpha-1 agonism, but also systolic blood pressure since it's still acting on beta-1. So our mean arterial pressure will rise and we get a reflex bradycardia, thus maintaining cardiac output. Isoproterenol, on the other hand, doesn't really affect alpha receptors so much, and we actually decrease peripheral resistance via beta-2 receptors, thus decreasing MAP. Beta-1, on the other hand, stimulates contractility and heart rate, which combines with a reflex tachycardia. So our cardiac output goes up, heart rate goes up, MAP goes down, and pulse pressure, the difference between systolic and diastolic blood pressure, goes way up. Finally, we have epinephrine, which has beta and alpha activity, but it's mostly at beta 2. So our beta 2 activity will lower our diastolic blood pressure, just like in isoproterenol, but not as much because we're still activating alpha 1 receptors, which sort of helps cancel that out a little bit. It reins it in. So our cardiac output goes up, heart rate goes up, pulse pressure goes up a little, but the biggest difference between isoproterenol and epinephrine is that MAP also goes up a little here, instead of down like in isoproterenol. But student Dr. Roman, what happens to epinephrine's activity in the body if we're blocking alpha activity with an alpha blocker such as phentolamine or prazosin? Well, I'm glad you asked. With or without alpha block, we have beta 1 activity and our HR, our heart rate, goes up a bit. But without alpha activity, we have unopposed beta 2 activity with epinephrine, which will significantly drop our diastolic pressure. The alpha blocker will thus reverse epinephrine's effect on MAP, as MAP will now be lower than baseline. What if instead of epinephrine we used phenylephrine, an alpha selective agonist, which is affecting alpha 1 slightly more than alpha 2? Well, this is a lot simpler. The alpha blockade will suppress all of the effects of phenylephrine, but it's not going to reverse anything. It's easier. So again, in epinephrine, the epi's effect on MAP will be reversed if we're inducing an alpha blockade. And that's all for today.